Okay. So we were discussing about the algorithms, right, in AI, and those are the kind of backbone. And it all started in the very late 80s, in the last century, when we were seeing the Gary Kasparov was beaten by Deep Blue, right, a supercomputer coming from IBM. That was the very beginning, you can say, the first triumph over human being, right, by one of our supercomputer called Deep Blue as prepared by IBM. But question is, what was running behind the scene, right? So there might have been a lot of algorithms fed into that supercomputer. There are a lot of chase moves were fed into the kind of computer, and that's how finally, after the lot of fight, finally Deep Blue could beat Gary Kasparov. I'm not saying that is the end of it, but that was just a kind of beginning. Now, I'm sure all of you now, let me give you an example which all of you will be able to relate yourself. So you must be hearing about in Indian context or maybe in global context, lot of elections, right? Where in the democratic country, like we are having a lot of predictions or a lot of elections, like sometimes we call it as a pre-poll prediction, sometimes we call it as a post-poll prediction, sometimes it is close, sometimes it is not even close, but ultimately those are driven by the random sampling of the data. Correct. Now, question is, how do you get to know, or what is running behind the scene for which this kind of prediction model comes into picture? Because these are typically called the unstructured data. Now, there are different type of data in the system. Some of these are called the label data or structured data. Some of these things are called the unstructured data or the unlabeled data. So there was a recent study happened in the UK that the UK, what should I say, like the the people, the doctors who were kind of teaching or taking care of the would-be mothers, like the gynecologists and the obstetricians, like they did a study. So for the would-be mothers, they took some of the data points, that whether it is a first time mother, whether she's having any complication, what is the age, and many other factors. And based on that, they were just checking what was the kind of delivery model for the first child, if it is a second child, whether it is a C-section delivery or a normal delivery. And they could find out a significant success in that model, that almost they could get into almost 90 to 95% of the accuracy in the right in that model. That okay, and whenever they're deciding that okay, this mother is a probable candidate for a normal delivery, so they are taking absolute care of it, right? And accordingly, they are processing them, right? They are giving them a lot of exercises, etc., etc. And finally, it is getting closer to that. Now, see, the accidents can always happen, the complications can always come at the runtime, but that's a different thing. But almost they were trying to get. It's not like our country, like the doctors are always forcing the mother to go for a kind of cesarean section. It's a win-win for both. The mother will not feel the pain, and the doctors will get their right surgery price. I mean, surgery fees, etc., etc. So I just tried to give you some example that how to relate, right? How to relate in this situation, and how can we get different type of case study around that. So today our class would be mostly on these. One of those prediction model called K-means clustering, and this can be used in various uh, case studies or various situations, right? We'll talk about those things. So K-means clustering, right? Today's topic. So where we have divided the section into or divided the lecture into few sections. The first section would be what is it, and what are the practical applications. Of course, we cannot cover all the practical applications of the K-means clustering here. So, but what is K-means clustering, where it can be used, and then we are going to give you a little bit of detail. And that level of fundamental mathematics, I'm sure all of us have done. It's nothing big deal, but it's a very simple thing. See, ultimately, none of us have to do this kind of mathematics on the ground, because typically the algorithms or the programs, those are written who will take care of this kind of right mathematical model. But what is actually happening behind the scene, sometimes like people feel curious about it, and that's the reason I thought of like sharing this information with you. Now these are the theory, and of course these exact algorithm model is to be replicated in Python or something, right? So that you can come up with your own AI agent. correct? And then you can apply that into different type of data. In fact, we did that we did that in couple of instances, and we found some right fantastic result, because we are going to show you the examples with maybe 10 data set, but the same model can be used for millions of data set. For 10 data set, you can do it manually, but whenever it comes to you with maybe 4,000, 5,000 people, you have to do the evaluation. It really becomes very, very difficult, right? So in that case, it may produce the result in a flash of a second. Now, forget about anything else. Now you go to a chat GPT, you give them the data set. Maybe you put them in an Excel sheet and you give them the data set and you tell them, okay, now these are my last year loan requisition, right? People, right? Let's say it's a bank, right? Let's say ICICI Bank or an HDFC Bank. And I'm sure you know that, like, before the loan, before they want to give you the loan, like, they do a lot of checks and balances. So, and they come up with a lot of form, and based on that, they will tell if it is, of course, if it is a certain amount, right, as a big amount. So they do a lot of analysis behind that, and based on that, it is said that, okay, the loan is approved. Now, on what basis they decide that the loan is approved? If it is a 4 lakhs, 5 lakhs, they will give it to anyone else based on your salary, because they have the salary data with you. But what about if it is a 40 lakhs, 50 lakhs, 60 lakhs, 1 crore, something like that? Or maybe a term insurance eligibility. What could be those factors? So, what they typically do is they feed these kind of millions of data into that. Even if you feed it in a kind of AI model, it will immediately give you a cluster, that which are the high risk profile, which are the low risk profile, and which are the kind of right moderate risk profile. In a flash of a second, you get that. But the question is, what is running behind the scene? What is the formula? What is the algorithm is running behind the scene? That is something what we are trying to learn today. Okay, so that is what is called the K-means clustering. So what is K-means clustering? What are the different applications? How it works? And then we'll go into the mathematical model, and then I'll try to show you, just to give you some. It's not a home task, but if any one of you are interested in doing the same thing and trying that out on your own, you can just try that out. Maybe you'll be curious. Okay, Shubho is telling about we can apply these, but actually how can we apply, right? So those things I'll be able to right share with you. So without further, let's quickly go into what is it. So K-means clustering is an unsupervised machine learning algorithm. So I don't know how many of you could recollect. We learned about a lot of things, right? Machine learning, deep learning. So machine learning talks about two type of algorithm. One is called a supervised machine learning, and another one is called unsupervised. Apart from that, there are two others called semi-supervised and reinforced learning, which we are not getting right now. But these are the two basic different sets used to group a similar data point into clusters based on their feature. The algorithm aims to partition the dataset into K clusters, where each data point belongs to the cluster with the nearest mean. Now, let me give an example of, right, one of my friend. I see that he has joined, Prashun Mojumdar. He is working with a CCTV. Now, you must have done, right, whenever you, let's say you are, you have procured CCTV from his area. He's a kind of provider and you are a client. And there may be thousands of clients, and Prashun may be maintaining. Prashun, I would like to go to Prashun for a moment, right, to take his view. Now, there is one-time purchase, and then after that, there is a kind of application maintenance. And he knows it very well, right? Out of my last year data, where and where I need to when and where I need to pitch in, right, for a application maintenance services, because that is where the recurring money is going to come to them, because they have to go and service and they come back. And again, depending on the model they are selling, they know it very well. What is the longevity, right, for that particular model, which needs a more regular maintenance, and which requires maybe right a later point in time. So would you like to just give us some idea about that, Proshun, like before I go further, because it's a real time environment, I would like to see from your end that how do you analyze these kind of data? And of course, I'm sure you are also providing the application maintenance service. You are not only installing, but you are also provide that maintenance service, even if you do it manually. But what is the logic you are doing behind the scene? If you can just share some of your point. Prashun, if you are able to hear us. Prashun, are you on mute? If you are able to hear us, would you like to share your thought? Okay. That's okay, right? He may not be in a position to talk, but that's okay, right? I'll kind of come back to him. So these are right the different type of things you do that. Like you buy a chimney or you go ahead and buy a car, and after that, depending on the car model and etc. There are many factors, right? They do the analysis. How many kilometers have it has run, right? What is the and based on that, you will get a right continuous call from the workshop that okay your car is due for a kind of maintenance etc etc, and that is true for a chimney or a Eureka Forbes filter etc etc, but they do these things. They don't do it, but there might be some algorithm running behind the scene. So this algorithm is to partition the data set into k cluster. K is just a kind of number, right, where each data point belongs to a cluster with a nearest min. We'll talk more about that. Okay, moving on. Now, what is it? What is the fundamental logic behind the scene? If you remember, I started the discussion that there are typically two type of data. One is called unlabeled data, one is called labeled data. Now, unlabeled data are the unstructured data where there is no logic, random data given to you. And sometimes the data are given which are proper labeled data, which you can understand. After seeing the data only, you'll be able to understand what is the meaning of this data. So those are called the labeled data. And we have some algorithm related to the labeled data as well, which we'll discuss in the subsequent session. But today we are going to discuss about some of the unstructured data. And based on that unstructured data, how can you partition them into into different clusters? Let me give a very simple example. Let's say Dola works in TCS, and TCS has multiple offices in Rajarhat, New Town. Now, on a day, like she needs to decide that okay, she needs to go for a go to office, but it's a very bad day. I mean, bad weather day. So which office would be nearer to her? Correct. There are maybe she's right staying in a location right where she can access multiple offices very quickly. So which one going to be a nearer thing for her? So she may be setting up one fundamental thing could be a distance, but if she wants to make it more complex, then what is the route, what is the traffic availability, and she can do all this stuff. And based on that, she can get okay there are four clusters. Now this is this class, and every cluster means something. Now let's say the cluster 1 means like it is 0 to 5 kilometer or 0 to 4 kilometer. Cluster 2 means it is 0 to 8 kilometer. Cluster 3 means it is a 0 to 12 8 to 12 kilometer, something like that. And then after that she can decide. Now this is a simplistic model, right, only based on the distance, but there can be many other factors. Okay, the distance may be more, but the route may be less crowded, and I may be able to travel quickly. There may not be that much of water logging, so she can decide accordingly, right? So I'm just giving some example. So basically, what we are trying to say: receive the unleveled and unstructured data, then infer the data into groups, and that is you are not going to do it, right? Your model will do it for you, and then you decide which one you want to go ahead with and what is the logic behind maybe obeying to that or maybe ignoring to that model. So discover, generate patterns and interesting structures. Now Kaustubh is also here. I'm sure like they are doing this kind of data analysis, right? Whether he does it, but big organizations may be doing it, or they may be having some software which can do this kind of analysis if they are feeding the data, and they can based on the pattern, like in the earlier sessions also we were discussing around that based on the earlier pattern, right, they can now come up with a right their behavior of the customer, and accordingly they can provide the solution, right? So this can be applicable for them as well. Now, baby delivery pattern. Now, if you are continuously, let's say, make my trip, let's say, let's consider a more structured model called make my trip. I'm sure they are doing this kind of model. Like, if you are always booking the hotel around, let's say, 2,500 to 3,500, it will never recommend you, right, a hotel which is beyond 5,000 or maybe beyond 4,000. It will always recommend the right hotel with maybe zero cancellation, right? What had been your previous choices, it will remember, and accordingly it will be providing right you those recommendations only. Now I told you about the baby delivery pattern, right, which recently happened in UK. Then pre-poll prediction, post-poll prediction, etc. Again, depending on the data, right, that they are receiving. So you must be hearing in the different debates there are a lot of discussions happening, but and sometimes different news channel may be coming up with a different type of prediction. Question is, are they accurate? No. Right? Are they predictable? Maybe, may not be. Right? There is no certainty. No one can directly tell if, of course, they can claim that, okay, it is very close to what we predicted, but there is never a surety that, okay, this would be the predictive model. Everyone does the same thing, but depending on the data set they have gathered, right, the data may vary here and there, right? So the more the data you get, the more sampling you get, your data accuracy will be much better. So unsupervised machine learning uses the raw input data without any explicit output variable. So it is just an unstructured data. You are taking it as an input. The goal of the unsupervised machine learning is to group the data into multiple clusters. Correct? Now, as I was telling that whenever you are going for a term insurance, like I was speaking to one of my friend, and he was saying, Shubho, always disclose everything. Don't hide anything, because if you hide anything, and at later point in time, if you die out of something else, right, people will, the claim settlement will be very difficult. So it is always good to go ahead and, right, disclose everything. Go for a thorough medical checkup. There may be a lot of policy, I mean, the insurance policy holder, not holder, the companies, they will come back and tell you that, okay, we'll go ahead and give you the claim, give you the term insurance without any medical. In that case, your premium will be much less. But actually, it is going to put you in a lot of trouble whenever the actual claim settlement comes in. So better, right, not to get into those kind of traps and try to provide as accurate information as possible. Next is, the idea is not to predict an outcome variable, but to understand the pattern. It's not a predictive analysis. Predictive analysis we'll learn later. But this is more of a kind of, right, a clustering model, a groupism model, right? So which you can, after that, you can choose. Input data is just a mixture or a cluster of the data, and the output is explored high-level types, as I was telling, right? Some of the clusters. So algorithms are used to discover and present the interesting structure in the data. Algorithm receives the unleveled data, as I was telling, raw data that has not given any tags or levels, that, okay, it's a good data or a bad data or any other, no other information is associated with that. Only thing that you know, these data represent this type of column. That's it. But after that, whether 10,000 minutes a good data or a bad data, there is no reason to that. Now, let me give an example. Now, if I say that, if I already define that, okay, 95% or more, right? You know that, like those who are student out here, you know that in the report card, what is mentioned? That A plus means, right, it is excellent, right? A to A plus means it is very good, right? Then B plus to A, it is good, something like that. So that means you are giving a labeling to that. And after that, whenever you get the report card, you may not be knowing the thing, but people will get to know, okay, which label I belong to. They predefine it. It's not that they are first getting the raw data and then they are coming up with the cluster. No. Correct. That's the later point. That is actually kind of unstructured. But here you are, after seeing that, okay, you have got an A plus, you understand that, okay, I am a labeled person here. Correct. So because I have got A plus, right? So that is the difference between the labeled data and the unlabeled data, and many more are there. Now, what are the other uses? I already gave you some of the example, but let's quickly move through. Now, customer segmentation, right? Retail and the e-commerce. So group the customers into clusters like bargain hunter. Now, these guys are always very much bargaining, right? You go to a Goriahat market and just see that the ladies mostly, right? If someone asks 450, they will start with 45, right? So that level of bargaining they typically do. And again, based on their historical data, right? And it's very difficult to bargain when typically that's a, right, with all due respect to the lovely ladies who have joined these sessions, but typically whenever a guy goes there, it is much easier for the shopkeepers, right? But typically, like if any lady goes there, especially on the hawkers area, right? Some dupatta, they are saying, okay, they are asking for 250, they'll start with, let's say, 65. And come on, like it's no way coming to the comparison. No, no, you come down, I'll go up, right? And the bargain continues. So they are the bargain hunters. Now there are some people who are frequent buyers. Oh, you came here once again, so good. So a little bit of special privilege they are going to get. And the premium buyer based on the purchasing behavior, demographics, and the browsing pattern. I can give you another fantastic example here called hotel reservation cancellation. So typically when we go for a hotel reservation cancellation, It gives you different type of flexibility depending on your check-in pattern. Like those who are guest users, right? Probably they do the check-in once in a lifetime. For them, there is no flexibility. Only one basic rule. But if you're checking into the hotel maybe once in a every year, you will see that okay, you are becoming one of the privileged users. If you are checking in every quarter, right, or more frequently, you become a super privileged user. And since I worked with IBM for 15, 16 years, I used to be a corporate customer. And for corporate customer, it's absolutely flexible. You can cancel the reservation before 6 p.m. of the check-in date and still you can get 100% refund. Of course, that is for the IBM approved hotels, right? Not for any other hotel. So this happens. So benefit, personalized marketing, loyalty program. Now, I'm sure all of you know that, like this is nothing to tell you, but you all know that you all have been using the Amazon. So are all of you getting the similar type of recommendation? Of course not. So depending on whatever you are seeing, right, or how you have purchased in the previous, you will get the things according. These days we get direct call from MedPlus. They do these kind of things. See, are they going to do and right track these things manually? Of course not. So based on the billing they are doing, right, they get the immediate intimation. Okay, it's almost 30 days. You now give a call to this customer. He's a repeat customer for us, and we keep getting call from the mainframe. Sir, you have not purchased this month's medicine. It's something like that. So it goes on and on. Now, coming back to banking financial, I think I already spoke about that. We'll not spend too much of time. Credit card risk assessment. So whenever you're going for credit risk assessment, so either going for a kind of credit card or a loan application like high risk, medium risk, low risk category, right? You can do that. I'm just moving a little faster because actually we need to go into the kind of algorithm part. Then the healthcare, patient segmentation, group patients based on the symptoms, age, medical history to the identify the disease pattern. So you must have heard, I mean, you all of us have seen that comorbidity patients, right? That point in time, like people were kind of hiding a lot of data whether the patient actually died of COVID or it was because of COVID plus comorbidity, correct? And every time the government was trying to hide the data, just marking them as a comorbid patient, something like that, correct? So customized treatment plan and the resource optimizations accordingly. Then another thing could be marketing. Like the other day, right? My friend was there, Kostov. So he's into kind of marketing. So segment markets into the cluster based on the customer preferences, geography, and the behavior. So he is going to the kind of rural areas and non-metro cities because those are still unexplored areas, and it is very easier to tap them, correct? Because those are not that much literate, etc., etc. So whatever doctor will say, they will consider it as a kind of Bible, correct? So that is another targeted advice. I mean, advertising and the product placement. Now, another thing could be telecommunication, that is the churn prediction, the cluster used based on the call pattern, data usage, and the complaint frequency, right? Predict potential. So, based how do they come up with now the area that I stay in Bangalore? Now, the you cannot imagine the kind of pathetic network that I get over there, right? So Vodafone does not work, right? I only have to rely on the Geo, but I don't know like whether they are doing any type of analysis or something. But remembering that when I was staying in West Bengal that time because of ILA, Phony, Funny, etc. Those um, after those catastrophic event, right? We had to complain Vodafone, and they said, yeah, our towers got impacted, so we are just trying to restore those powers, right? Towers, etc. So this is how it happens. They do a lot of analysis accordingly. Next is the last one, the traffic pattern analysis that cluster GPS data to identify the high traffic zone and the peak travel time, right? I don't want to comment on Bangalore here. In Bangalore, in the peak time, just to cross 100 meter, maybe Asim can also share his view. In peak time to cross 100 meter, it takes almost an hour time. Think about 100 meter. Usain
Very
Bolt
much.
runs 100 meter in 9.5 seconds, correct? To cross that 100 meter, it takes easily, right, 1 hour time. And you can just see the only car and car and car, right? Nothing else. And nothing is moving, stand still, correct? So it is a very good case study for a mileage, right, for a car. I don't know. right? Whether in Bangalore there is a special kind of things happening or not. But this is fact. Now, coming back to education, student performance grouping, right? So, cluster student based on the attendance, grades, and the engagement levels, of course. Now, these days, there are a lot of online studies that are happening, a lot of tuition groups, right? Fiji was there earlier than that Baiju. Now, those both have got scrapped. Then Physics Wala, Alan, Akash, right? Many other, right, things are there. I'm sure that they are sending us a daily report or a monthly report or a weekly report to the parents that okay whether the student is coming, joining, listening, what is the performance pattern, etc., etc. Right? So I'm sure 100% that maybe in next few years, right, the teachers have to do the same thing because it's very difficult for a teacher to remember all these analyses, right? They do it fantastically today, right? I sometimes get surprised that okay, whenever we are attending the PTM, how come they could recollect all these incidents? But that is their job. But they can do it even in a much better way if they use some of the tools, right, etc., etc. So without taking away any credit from them. So now coming back to the actual part, that actual how it is happening. So first of all, choose the number of cluster. Right now, you can choose the we can always start with a basic because you cannot choose only a single cluster, right? You have to choose at least two cluster, choose two choices. Maybe you can say good or bad, or good, medium, bad, or something like that. But there is no restriction, right? Depending on your data, depending on your pattern, you have to choose. Then initialize centroids. We'll talk about that. What is centroid? Centroid means you need to just pick any of from the random data set that you are going to get. You need to pick any two of them and then try to cluster the data around those two centroids. Correct? Like as I was telling, that if Dola has to travel today, right, to either Lord's building or to Gitanjali Park. Now these are maybe out of various offices, Lord's, Eden Park, STP2, Gitanjali Park, InfoSpace, and many others. I'm just picking only two. Now, which one she should go into, right, in a difficult day? Correct? And accordingly, like we'll figure out, and these centroids will change. Maybe in the first round, the centroids are Lords and Gitanjali Park. Maybe in the next round, it may be EcoSpace and STP2, right? I'm just giving some examples. So assign the data point to the cluster, update the centroid. That's precisely the point I was telling. In every time, the data is changing. When we see after two iteration, there is no change in the centroid, that means we have reached the correct prediction model. I repeat, in the first situation, let's say it was like Lords and then the Gitanjali Park. Next time, right, it has changed one of them. But later point in time, whenever you see that there is no change in the data, we'll talk about it. We'll show you in detail. Then we decide that okay, we have reached to that, right, the best level, the best. So repeat continuously. So now please listen carefully. So much of discussions happen, but now we are actually going into the how it happens behind the scene. So imagine a data set with some random data. Let's say 2, 4, 10, right? It's a distance. Let's say it's a distance from your house. 2, 4, 10, 12, 3, 20, 30, etc., etc. Out of that, I have highlighted two of them. Why I highlighted? Those are kind of random centroid that I have picked. Now, it's not that, okay, you have to pick these two. You can pick any other. You can pick 3 and 30. You can pick 10 and 20. Only thing is, right, the number of iterations, the ultimate result will be same. The number of iterations, right, will change. So we need to divide them into different clusters using k-means clustering. How it happens, I'll explain everything. We use Euclidean distance method to arrive at the cluster. Very simple, right? That level of mathematics, I'm sure all of you can remember. So what is the distance of one point, right, to another point? So there are 2 points, let's say X and Y, and there is your point called C. So what is the distance between C and X, and what is the difference between C and Y? Depending on that, you need to decide that whether the C belongs to cluster 1 or C belongs to cluster 2, and that we keep repeating for all the data set. So initial cluster centroids are M1 is equal to 4 and M2 is equal to 12. I'll show that. Everything I'll show you, right? As I told you that 4 and 11 are picked as two centroid. And let us apply k-means clustering algorithm and create two clusters. Question, why two clusters only? Can we get more clusters? Of course, you can get more clusters. So this is just for the simplicity. I have picked two clusters, but you can choose any number of clusters. Of course, that your calculation will be right, little bit complicated. That's it. But you can choose n number of parameters or n number of cluster. Now we are actually going into the point, and I'll try to go very slow. If anyone does not understand, right, please raise your hand, because it is very important. You guys are spending time to join this session. Please make sure you understand this. Okay. So let's come back to the little bit of the calculation that we do behind the scenes. Simply, I told you already that we try to create a Euclidean distance formula, right? So let us say like A and B, these are the two centroid, right? So what is the typical formula of A and B? Sorry, it's a formula between distance between 2 points. So simple, x2 minus x1 whole square, y2 minus y1 whole square, whole over a square root. So if your point is, let's say C, which is x and y, then it can be x2 minus x whole square, then sorry, x1 minus x whole square, then y1 minus whole square. That will give you one cluster, one centroid. Another would be, right, x2 minus x whole square plus y2 minus y whole square, whole, right, whole square. Sorry, whole square root. It will give you another point. And then we need to decide, okay, which one is nearer, and accordingly we'll decide which cluster it belongs to. We'll talk about that. Now, what if, like, as I was telling, what if we had more cluster, three-dimensional data set? Simple. Only thing is, instead of x and y, we need to add now one more variable called z. So again, x2 minus x1 minus x whole square, y1 minus y whole square, and z1 minus z whole square, again whole square root. If it is a 4 parameter, right? So in that case, we need to come up with a 4 different data set. Let's say here we are not calling it as x1, y, x2, x3, and x4, and accordingly we do the calculation. So now let us coming to the actual discussion, and I'll try to go very slow and try to show you with some right mouse pointer as well, correct? And try to understand very quickly. So let us say this is our data set, correct? Now let's say the TCS is having these many offices, right, from, I mean, these many offices, and this is the distance, right, from my house, let's say, for consideration for now. Now I have to divide these offices into two clusters, correct? So which one belongs to cluster 1 and which one belongs to cluster 1, accordingly she can choose. So the formula that we are using, I have picked two centroid for now, that is 4 and another one is 11. These are the 2 points that we have chosen, correct? Now what is the formula I told you? That x, now this has of course two component, right? So what are we doing here? Every time, right, this is your point 2. So 2 minus 4 whole square, it is the second one, right? 2 minus 11 whole square. So x1 minus x whole square, x2 minus x whole square, right? That's exactly what we are doing here. It's the only single point, so only x, right? So not even x and y, it's a one dimension. Now, so similarly, when I come to this 4, it becomes 4 minus 4 whole square here, and here it becomes 4 minus 11 whole square, that is 7. Now, next time, right, if I come to 11, right, again, 11 minus 4 whole square is 7, of course, 7 square, and here 11 minus 11 whole square is equal to 0. So every time we use that, the first time, right, we use that point, like this point has to be common, right, in both the cases, 2 and 2. In one case, you have to minus this, I mean, subtract this 4 from 2, and in another cases, you have to subtract this 11 from 2, right? So this is how you're doing it. Now, how are we, right, putting them or organizing them in a cluster? So in which case, you will see M1 less than M2. So whenever you are seeing that M1, right, is less than M2, M1 is less than M2, then it falls into the C1, right? As you see here, 2 is less than 9, C1, 0 is less than 7, C1, and 1 is less than 8, it becomes C1. But whenever we are seeing M1 is greater than M2, right, it becomes C2. See, this one greater than, this one greater than, this one greater than, this one greater than, this one greater than this one. So this is how we are generating our C2. Now what I told you that based on these new clusters which are formed, we need to update our centroid, because that centroid was just an initial consideration. So now my C1 becomes 2, 4, and 3, and this C1, C2 becomes this one. Now we have to take a mean. Correct? Simple arithmetic mean. So here we have got three parameters. So 2 plus 4 plus 3 divided by 3. See, 2 plus 4 plus 3 divided by 3. That's it. Now, whenever it comes to M2, there are multiple data, 1, 2, 3, 4, 5, 6. So we are just adding them up and dividing by 6, and we get the right new centroid, 18. So first centroids were 4 and 11. So now we are getting the new centroids, right? Your 3 and 18. Any question from anyone so far? Right? This is our first step, right? How the clustering works. Now the next step is, now we have divided 3 and 18. Same logic again. Again, you have to subtract this 2 minus 3 whole square and 2 minus 18 whole square. Correct? Similarly, for all of them, you have to apply the same technique. You take these numbers, subtract 3 from there to get the first number, and then you subtract 18 from there to get the second number. Absolutely same technique. Again, the same logic, right? Whenever you see that it is less than, right, then these are becoming your C1, right? All these are C1. And whenever this is becoming more, you will see like this becomes C2. But the problem is, in the first cluster, right, we were having, this is C1, C1, and C1. Probably this one also C1. Let me go back, right? So then C1, C1, and C1. Okay. Now this time, the next time, right, as you see, I have got one more extra C1, which was not there, which was earlier C2. Correct? So this is the highlighted area where you see there is a change, a shift in the cluster. Earlier, the point 10, right, was belonging to the cluster 2. Now it has changed to cluster 1. So that means we have not come, or 4 and 11 did not give us the accurate clustering. Correct? So now we have to go for one more round, right? So since whenever you see there is a change in the cluster, you have to go for a second round with a new centroid. So now the new centroid becomes C1. All the C1s, it has become 4, 3 to 4, and it has reduced from 6 to 5 naturally, because you have to have the 10 data. So then you are again adding it and dividing by 4. It gives you new data, that is 4.75. And this one you get the 19.6. This becomes your new centroid. Again, you know what to be done, right? You put the same thing. Now this time your M1 and M2 changes to 4.75 and 19.6. Again, the same logic. 2 minus 4.75, 2 minus 19.6. Similarly, that applies to all of them. So again, you do the same calculation, and now you see again, right, sum. So this becomes C1, 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 right? Again, this becomes C2, C2, then C1, and then again C2. So now you see there are two areas where I see there is a shift, right? In earlier cases, there are two, that point number 12 was C2, now it has moved to C1. In the point number 11, it was, right, C2, right, now it has become C1. So that means again, we have not yet reached to the, right, final clustering. Correct? We have not reached there. So what to do? Now we have to go for one more round. Now, of course, before that, what I had to do, like we had to change these clusters, right? Now we have got 7 here and 3 here. It has changed completely. So now the next is becoming, right, this one and this one, because we have got around 9 data, right? So we have got the new centroids. Again, you apply the same technique, right, using the, right, new centroid data, right? M1 is 7 and M2 is equal to 5. Again, the same logic, 2 minus 7, 5 whole square. Again, 2 minus 25, that is 23 whole square. So ultimately, you get the number. Correct? Same logic you apply. But now this time, if you see the cluster and the new cluster, there is no change. Right? The same cluster which were there in the previous iteration and the cluster that you are getting as a kind of new cluster after this calculation, that means there is no change. So that means, what does it mean? It means that M1 is equal to 7 and M2 is equal to 25 become my absolute centroid. And all these items, right, between 2, 4, 3, 10, 12, or 11, they come to one cluster 1, and the other one, that is C2, C3, and C5. So anything beyond 20, 30, and 25 becomes your, right, next cluster. Correct? So now Dola can decide, okay, which all offices coming into cluster 1 and which offices are coming to the cluster 2. And depending on right which one is nearer, she can choose and she can go ahead. So we are just dividing them into two clusters depending on certain parameters. So this is how the clustering works, that we kind of come up with the right two level of grouping or two level of clustering. Now in the real time example, now so far I have shown you with a very hypothetical example, but in real time situation we are not going to give into any details further. I'll try to just show you that, okay, can we really rely on one parameter? So far we were talking about only distance. But can we really work on only one parameter? Of course not. That will be a biased result. So I really need to come up with, in fact, in this case also, only the distance matters. But can we really define on the distance? Can we really decide on the distance? Of course not. There may be a lot of other parameters that you need to consider. So here also we are coming up with, let's say, real and the e-commerce. So to segment retail and e-commerce customers into distinct behavioral groups using clustering in order to enable target marketing, customer retention strategies, and personalized experience. So here we are considering, now question is, it is very important to identify the right parameters. Correct? So here we are considering three parameters. Annual income represents the customer's purchasing power. Now, I cannot suggest anyone, right, to go for a Samsung smartphone or an iPhone smartphone, I mean, with all due respect, whose right monthly income is less than 10,000. Not possible. Correct? Because they, even if they go by EMI, they will not be able to pay the EMI. What is the point? Right? So it's a risk. Next is spending score. Now, you go for, like, I go to, let's say, HDFC Bank or any other bank and asking for a credit card where it gives me a lounge facility because I have to travel a lot. And then they say that, okay, sir, if your salary is so and so, greater than so and so, if you spend in the last three months, quarterly spend is greater than so and so amount, then only you become eligible for this, right, special credit card, which can have a lounge access. Otherwise, you have to pay for it. So then we'll see that they will do that analysis once I give them the details, and then they'll decide, okay, which card I am kind of eligible for. So spending score, like almost kind of same thing, reflects how actively and heavily the customer spends compared to others. And finally, the purchasing frequency indicates how often the customer make the purchase, right? I was telling you the example of MedPlus. So depending on, right, they are coming up with three type of cluster here. One is an engaged but low income. So low income customers who are highly engaged spend frequently and actively. There may be certain customer who may not be having that much of salary, but they spend very Blinkit. Let's say they are using Blinkit quite often. It's all about, they may not have time, right? So it's not about that affordability. There may be various other reasons for that. Then moderate segment, customers with a balanced income, spending, and the frequency. This is the core segment. There we are having the maximum population. And then the wealthy but low spend, high income customer with a low spending, right, and low engagement, underutilized. They can afford, but they are not. Maybe they are a lot more invest minded. Correct? So these are the examples of the real life examples of how you can come up with a pattern accordingly. They have shown you the last column as the result. But what all things you have just learned, you can apply the same technique using those three columns, and you can also arrive to the same, exactly the same segmentation after 2 or 3 iterations. So that's the reason I wanted to show you that how in real time you can use this technique. Of course, we are not going to do it with the thousands of data, not possible. In that case, we need to take the help of the Python programming or the AI agent, right, which is running behind the scene. Another example, banking and financial. To segment loan application, the example I earlier gave, based on the risk factor using k-means clustering, enabling the bank to financial institution to assess credit worthiness, reduce default risk, and personalized role offering. Now, always remember, guys, there will be some outlier which you need to ignore. Because here, once you are doing it, immediately the question may come to your mind. Can't we track Nirav Modi? Can't we track Mehul Choksi? Can't we track the big corporates who are continuously becoming defaulter, but still the right credit card, the bank is coming after us who are only taking 5 lakhs, which is just nothing to them. But they are becoming, those guys are who are taking 5,000 crore, 7,000 crore, they are becoming defaulters, and those pressures are coming on these low people, correct? Low income people. Now, I would consider, let's not get into the debate, but we will consider those as a kind of outliers. Because you may not be getting too many people who are going for that 5,000 crore roles, though they are over, right, shadowing everything, correct? But still, those can. So whenever you are going to come up with, you should not consider the outlier. You should consider you where in that segment where you get the maximum data set. So here, what could be your top three variable? Credit score, could be annual income, could be debt to income ratio. That means what is your income versus how much debt you are also in, correct? So depending on that, they can decide, okay, whether it's a low risk, moderate risk, and high risk. You know that, like, had Joyantu been there, he would have given us some highlight here. Now, what is the logic behind that CIBIL score? Definitely, there are some similar kind of exercise being done in the background, and accordingly, they go ahead and do that. How do they identify who is a premium customer? Correct. So they do this kind of analysis and come up with that. And the last slide for today, that is on the healthcare. To segment patients based on their key health indicator to improve the care delivery, personalized treatment plan, and optimize the hospital resources. So one is definitely could be an age. Let's say whenever you are going for how the term premiums are decided. So if you are going ahead with a term insurance premium in the age of 25, and if you are doing the same thing at the age of 48, right, naturally your premium will be much higher because your risk profile will be much more. By the time you might have, right, might have become vulnerable, you might have picked up a lot of diseases which was not there in the year of, let's say, 2025. So here the premium rate will be much higher. So earlier, like they will always suggest, right, go ahead and do the right term insurance ahead of time. Just giving some example. BMI body mass index. Now my body mass index is going beyond it. It is not even measured in any particular machine, right? It is so big, right? So it happens like that. Chronic conditions, right? The number of chronic illness, diabetes, hypertension, asthma, etc., etc. So depending on that, they decide whether it's a young, healthy, middle age at risk, and elderly at high risk, and accordingly they will decide that what will be the premium, etc., etc., or maybe what is going to be their right patient, the which unit like they have to be given, correct, for their treatment, etc. So I'll stop here. I would like to hear more from you guys now. So if anyone has any such example who are using this kind of clustering behind the scene, would like to. So today I can assure you that your example will not get cut because it's a premium version of Zoom. So if anyone would like to highlight any such situation, right, please do so. Thank you so much. Prashun, I was earlier taking your example. If you're available, we would like to give you some of your whenever you go for a let's say CCTV installation, and after that you. Sorry, go ahead.
Sorry, what previously as a network problem in my.
I could get it. Yeah. So can you just help us understand how do you determine your AMS customer, that where you offer the maintenance services? Do you do any such analysis based on the last 1 or 2 years of data?
Yes, sometimes basically, we are from basically the system integration part.
Correct.
And the maintenance is another part that we are offering our customer to also. Generally, there are two type of maintenance going on. One is scheduled maintenance and another is the preventive predictive type of maintenance. So here AI comes basically for the non-scheduled type of maintenance.
Right.
Because our main aim to reduce this non-scheduled maintenance.
Correct.
Because frequently machines goes down. So basically here AI help us a lot of customized and maintenance type of data because these are more forecasting type of report we are getting from this AI enabled sensor based.
Exactly. That was my point. Yeah.
Yes. Because some sensors are putting in around the machines area. And here we get some prehistorical data set some logic behind that, some the DSS support system there,
Correct.
some expert system are going. So basically, these are the customized AI-enabled solutions that some L&T and other some other organization also there. They are developed this type of solutions, and basically you are procured this type of customer solutions from them
Hmm.
and offering the customers to get the actual feedback and actual the maintenance. We just our aim to reduce the maintenance cost and time, and based on the this type of software centric data,
Hmm.
we generally get the idea when the machines will go down, and
Okay.
then some backend some maintenance are going on. So, but this is not not properly functioning all the times. It's
Correct.
also in the is also now in the R&D stage.
Right.
These are also these are all in the R&D stage, not
R&D says still
yes,
exploding, not yet
yes, yes, yes,
reached that
yes.
level of maturity.
Not fully operation, not fully
Correct.
functioning.
Correct. Correct. No, no.
There is a term going on in the industry, the factory 4.0,
Right.
industry 4.0. These type,
Hmm.
so these are all come under this type of solution.
Excellent. And
That's why I'm
hmm.
more interesting that Shivabato, that maybe your team also developing this type of solutions. So these are also helpful for us.
Oh,
That you
okay.
are
Okay.
that you are getting the you are
Uh,
actually
I can tell you I
solution.
can tell you what is going on, Broshun. Still in every organization, right? We have got many organization participation here also in this forum. Still in no organization there is a concrete use case customers are asking for. Everything it is a
Yes, yes,
POC.
yes,
So
yes,
far it is
yes, yes.
POC because still it is so evolving, right? As I was telling the other day, it is AI is still very probabilistic. It is not an yet level come to a level of
Yes,
deterministic, right?
yes,
And every day, today whatever is there, right? Tomorrow it is becoming a hype. Tomorrow it becomes obsolete and something else comes
Ab-
up. So
absolutely, absolutely.
right. So things are changing so fast that it has not reached to that level of maturity that okay, no one, someone can come up with a concrete solution. But I'll keep that in mind. Okay.
Mm.
Anyone else would like to just share anything before we wind up?
Because Shubham, if
Mhm.
today's market, if
Mm.
any product missing AI tag,
Correct.
it's very difficult to sell that product.
Absolutely. Absolutely.
So everybody is now come up with some any type of solutions, any type of product, and mention is a AI enabled.
Correct. AI enabled Internet of Things, right? These are all
Yes,
becoming a
yes,
kind
yes,
of
yes.
right unless and until you do that, unless you do that
Yes.
integration properly, right? Nothing is going to
I think
happen.
in surveillance, in our another part is the surveillance sector,
Correct.
security and surveillance sector. There's a lots of customized, AI enabled cameras are there.
Very true.
So
Mm-hmm.
these really functioning well.
Mm-hmm. Mm-hmm.
Some analytics software is there. So basically, another day we will discuss in details
Mm-hmm.
that how these AI enabled, software solutions help
Mm-hmm.
cameras and the city and the
Definitely.
surveillance.
I would like to hear more
Yes,
from
yes,
you.
yes.
Yeah. Yeah.
Yes.
Shreya and Rashika, I know that you are from Kaustubh stream, if I'm not wrong. Would you like to just share something, right, from your perspective that are you still using it as a kind of manual task, or are you seeing any possibility of using AI, or maybe you are using any software to do that for your customer analysis?
Good morning to everyone. I'm
Uh-huh.
Rashika from Dreamscape Holidays. I
Uh-huh.
hope I am audible.
Yes, yes, you are very much loud and clear.
In AI, we definitely use AI. When we actually book the flights or check the flight details,
Uh-huh.
there the AI is used. They actually when we check the details of the flight frequently, they actually raise the prices a bit
Correct.
higher.
Correct.
And also in hotel bookings we use AI. And also there are few more apps like Europa Munda and Vina World. They give us the whole itinerary as well as the
Exactly.
whole tour guide, and as well as the hotel details and everything. All the details are given there. So yeah, AI is actually frequently used in uh, our sector also.
Mm-hmm.
But in the flight sectors, the AI is used higher more than the hotels and anything, because
Correct.
we can also book the hotels offline, and
Mm.
uh, we can also hotels the book from any app, but in flights they just see that how much more we are more frequently we are looking for a flight, then if after few minutes only if I check the flight again, the
The price gets
price gets
higher.
a bit higher. So
That is true.
it becomes a problem for us sometimes, but other than
Because the
that we
quote you are
also
making to
book.
the client, and immediately whenever you're trying to book that, by the time it has got high, right? So,
Yeah, that becomes a problem for us for the quotation. But in the
uh-huh.
hotels booking, as I have also heard about MMT, Agoda, and a lot of things have now come out in an AI platform
uh,
from where we actually book the hotels. But in TripAdvisor, there are few comments and reviews which are automatic generated there. So AI in our industry is mostly used in flights and for the flight details and for the prices for.
so if I understand you correctly, you are still doing it for a transactional basis. You still don't do a customer analysis like or the previous customer data to understand their pattern, etc. You still are not into it, if I'm not wrong.
No, we do the customized basis more.
Okay. Uh-huh.
You are absolutely right there. Thank-
Hmm. Okay. Okay. Thank
So
you. Thank you. Go ahead,
this is
Rashika.
thank you so much.
No, no, no. Go ahead. Go ahead. If you want to share something. Sorry, I did not
No,
mean to cut you.
That's all.
Okay. Okay.
That's all for the AI use in our sector. Thank you so much for giving me an opportunity to share my
Of
experience here.
course. Of course. Right. It is everyone's forum. Anyone else would like to share anything?
Shubhabrata Dola here.
Uh-huh.
So, so you spoke about the outliers, right?
Correct.
But through this simulation,
Hmm.
because this is going to be done automatically,
Mm-hmm.
so this will treat all the data points equally, right? Uh, and if there are any extreme data points, then these outliers will distort the entire clustering
That's precisely
process,
my
right?
point. That was precisely my point. Let's say here, as you saw, right? So I took the distance between 2 to 25. Correct. Now there may be one TCS office which is at Kalyani. I'm just giving an example.
Hmm, hmm, hmm,
Correct.
hmm.
So which may be 175, and which will distort, right, the entire calculation. So for now, you have to just try to come to a range where you can get your desired result. Maybe for a to include that Kalyani TCS office, or maybe Panagar TCS office, you may need to again come up with third cluster or something like that. But if you try to bring that within this cluster, that may jeopardize your entire calculation. So that's the reason I was telling, let's not consider any outlier. So that's a kind of disclaimer that we want to take, because otherwise your algorithm should be written in that way that which is not coming on following in a
Correct.
particular pattern, right? You should discard that for the time being,
So
because
the
if
data you feed in into that algorithm, that is going to be, that itself
absolutely,
needs to be reviewed and
that is
right.
where the data mining, data engineering, data analysis, all these things are coming into picture.
Correct,
Why are they
correct.
required?
Mm-hmm.
Correct. The
Got
data
it.
analytics are actually going to do the kind of similar distance. Now, like say, like as Rashika was telling, if we get to know about only one customer who did, who kind of worked with Kaustuv maybe for once in a lifetime, but after that, so can we really understand their pattern? No, we cannot, because maybe at that point in time he has done that, but after that we don't have any historical data, right, to understand that customer. So for now, maybe we'll figure out or we'll try to do an analysis on a certain customer who has at least done, let's say, 5 times with Kaustuv. So now he can understand that, okay, from that 5 data set, I can understand the customer's pattern. But with just one data set, it is very difficult to draw a pattern, right, for that particular person. And that is happening everywhere. It is not that, like, even if you work in our normal model also, right, our working model also, can you really decide whether the person is good based on just one project performance? You cannot,
Correct, correct.
right? You
So
have
you
to see
need
the kind of
multiple data sets,
absolutely,
right, to
absolutely,
arrive at a conclusion. Okay.
absolutely.
Yeah, great.
And that is
Thank you.
and that is one of the reason these days if I may go to Shukanna, I don't know what is the background. So earlier I was also thinking, why so much of exams people are taking? Because in our days, like we were only that whether the student is good or bad, it was only decided based on a half yearly, right, or an annual exam. But now Shukanna can help us understand that how many exams they are taking day to day. So maybe I don't know, maybe 4, 5, or 6. I don't know how many exams they are taking. Shukanna, would you like to just share that, right, for class 11, 12, or class 9, 10? How many set of exams for each subject you are taking? Because why they want to do it, just to understand, it's a holistic evaluation. Sometimes it's become too much on the teachers though, but they try to come up with a holistic evaluation that maybe it may so happen that on one particular day, right, during that 80 exam or 100 marks exam, right, the person was not well, but that should not be the evaluation. We should not be penalize the student, right, for that only one day performance. But if we can get a holistic performance throughout the year, still even if that in that exam he has or she has not done good, but she can still be considered as a good student, right? So Shukona, if you want to just share one of your view out there.
Yes, you're right, Subrata. It's a holistic approach now, and there are three exams almost, yes, for each of the classes.
Mm-hmm.
For the holistic approach, we have to take 3 exams per year.
Okay. Okay. Apart from that, do you consider any class test or something like that which are for a
No,
continuous evaluation? No, only 3 exams
no,
that you take.
it
Okay.
is a continuous evaluation.
It's a
Yes,
continuous evaluation process. Okay.
yes, yes, yes.
Okay. Okay. But I'm sure like when Rai did her, right, 11, 12, she had to go for, right, too many exams, like we were kind of
Yeah, too many exams.
too many examples.
She
Yeah.
had to take too many exams.
Okay.
Right.
Okay. Thank you. Thank you so much,
Thank you.
everyone. It was a great
Informative
discussion.
session.
Right.
Thank you
We'll
so
come up
much.
with something interesting more. Yeah. Take care. Bye-bye.